Hello everyone and welcome to my channel. This is class 2 of chapter 2 project planning and capital budgeting. The first question which we are going to do in today's class is question number 18 and it is on page number 2.27. Let's read the question first. Project X and Project Y are under the evaluation of XY company. The estimated cash flows and their probabilities are as below. Project X, investment year 0 is 70 lakhs. This is the initial cash outflow. Then we have been given with the cash inflows of year 1, year 2 and year 3 and these are the probability weights. Okay, so this means that there is 30% probability कि हमारे cash inflows जो होंगे from project X it will be 30 lakhs in year 1, 30 lakhs in year 2 and 30 lakhs in year 3. Then there is 40% probability कि हमारे cash inflows जो है from project X वो 50 lakhs होंगे in year 1, 40 lakhs in year 2 and 40 lakhs in year 3 and 30% probability है कि हमारे कैश इनफ्लोज जो है वो 65 लाख्स इन ईयर 1, 55 लाख्स इन ईयर 2 और 45 लाख्स इन ईयर 3 होंगे. ठीक है, तो ईयर 1, ईयर 2 और ईयर 3 का कैश फ्लो निकालने के लिए व्हाट वी आर गोइंग टू डू, हम जो भी हमारे एक्सपेक्टेड कैश इनफ्लोज हमें दिए हुए हैं उसे हम मल्टीप्लाई कर देंगे, ठीक है, बाय द रिस्पेक्टिव प्रोबेबिलिटीज. ओके, देन प्रोजेक्ट वाई के लिए हमें क्या दिया हुआ है, वी हैव बीन गिवन इन्वेस्टमेंट जो है कि हमारा 80 लाख रुपीज़ का है, दिस इज इनिशियल कैश आउटफ्लो, और एनुअल कैश इनफ्लोज जो है वो हमें दिया हुआ है एंड द प्रोबेबिलिटी वेट्स इज गिवन. मीन्स 20% प्रोबेबिलिटी है कि एनुअल कैश इनफ्लो 40 लाख होगा, 50% प्रोबेबिलिटी है कि 45 लाख होगा और 30% प्रोबेबिलिटी है कि 50 लाख होगा. तो इससे भी हम कैसे निकालेंगे, जो एक्सपेक्टेड एनुअल कैश इनफ्लो है उसको हम निकालेंगे बाय समिंग इट अप द एनुअल कैश फ्लोज, मीन्स द प्रोडक्ट ऑफ एनुअल कैश फ्लोज, ठीक है, एंड द प्रोबेबिलिटी. मीन्स पहले हम एनुअल कैश फ्लोज और प्रोबेबिलिटी को मल्टीप्लाई करेंगे एंड देन ठीक है विल सम इट अप, ठीक है, सो दैट इज द एक्सपेक्टेड एनुअल कैश इनफ्लो. देन the question has been asking us which project is better based on NPV criterion, take with the discount rate of 10%, compute the standard deviation of the PV distribution and analyze the inherent risk of the projects. Okay, so let's proceed on with the question. So we're doing question number 18 and it is on page number 2.27. Okay, so first we're evaluating project X. Okay, so I have to compute the NPV of the project. So for that I'm making a table. Years 1, 2, 3. Then I'm writing cash inflow. So for this I'll make a working note. Then PVIF at the rate of discount rate, okay, which in the present case is 10%. Then we'll find out the PV. Okay, then we'll sum it up. So this is what? This is the PV of cash inflows. और फिर हम इसमें से माइनस कर देंगे हमारा इनिशियल कैश आउटफ्लो, which will give us the NPV. Okay, so for computing the cash inflows, ठीक है, I'm going to make a working note. Computation of cash inflow. So year 1 ticket will be 30 into 0.3 plus 50 into 0.4 plus 65 into 0.30. Okay, we'll multiply it and then sum it up. So it will be, it is 48.5. Then for year 2 it will be 30 into 0.3 plus 40 into 0.4 plus 55 into 0.30. Okay, then again we will multiply it and then we will sum it up and the answer is 41.5. Then similarly for year 3 we will compute it like this, 30 into 0.30 plus 40 into 0.40 plus 45 into 0.30. ठीक है, अगेन ठीक इनको मल्टीप्लाई करके फिर उसका सम अप करके द आंसर इज 38.5. ओके, सो इस तरीके से हम कैश इनफ्लोज जो है वो हम निकालेंगे, ठीक है, फॉर ईयर 1, ईयर 2 एंड ईयर 3. ठीक है, वाई वी हैव डन दिस, ठीक है, आई हैव ऑलरेडी टोल्ड यू दैट कि हमें प्रोबेबिलिटीज हमें दी हुई हैं. ठीक है, इन द क्वेश्चन के अंदर ठीक है हमें ये चीज़ दी हुई है दैट कि 30% प्रोबेबिलिटी है कि हमारे कैश एंड फ्लोज इतने होंगे, 40% प्रोबेबिलिटी के कैश एंड फ्लोज इतने होंगे और 30% प्रोबेबिलिटी के हमारे कैश एंड फ्लोज ये होंगे। ठीक है, तो ईयर 1 का अगर मुझे कैश एंड फ्लो निकालना है तो मैं क्या करूँगी? ठीक है, ईयर 1 के लिए 30% प्रोबेबिलिटी के 30 लाख होगा, 40% प्रोबेबिलिटी के 50 लाख होगा और 30% प्रोबेबिलिटी के 65 लाख होगा। ठीक है, तो हमने ठीक है इन कैश फ्लोज को ठीक है मैंने मल्टीप्लाई कर दिया इनकी प्रोबेबिलिटीज़ जो रिस्पेक्टिव प्रोबेबिलिटीज़ दी हुई हैं और फिर उसको सम अप करके ठीक है वी हैव जस्ट फाइंड आउट द एक्सपेक्टेड कैश एंड फ्लो फॉर ईयर 1 इन द सिमिलर वे वी विल फाइंड आउट फॉर ईयर 2 एंड ईयर 3. Okay, so this is the way that we have find out the cash and flows for all the 3 years. Take now I'll code them here. So it is 48.5, it is 41.5, and then it is 38.5. Okay, then we will find out the PV. I have to calculate of 10%, which is the discount rate. So 10 divided by 100 plus 1 divide equal. So it is 0.909, then it's 0.826, and then it is 0.751. Okay, now we'll multiply it. So it's coming 44.09, 34.28, 28.91. Now we'll sum it up. It's coming 107.28. The initial cash outflow in case of project X ticket is 70 lakhs. So that is investment ticket year 0 में जो आपको दिया हुआ है. So which is 70 lakhs. ठीक है, तो यहाँ से हम उसको माइनस कर देंगे. So the NPV is 37.28. ठीक है, so in this way we are going to find out the NPV ठीक है of project X. Now ठीक है we'll be comparing the NPV of project Y. Okay. So again I'm going to make a table which is year 1, 2, 3, then cash and flow. Okay, for this I'm going to make a working note which is working note 2, then PVIF to calculate of 10%, then present value. So the sum total will be your PV of cash and flows. इसमें से माइनस कर देंगे initial cash outflow and the answer will be NPV. Okay, so the working note 2. So here in case of project Y ticket is given that the annual cash flow ticket throughout the life ticket has been given, means in every year we will be having the same cash inflow. Clear? तो वही हम निकालेंगे annual cash inflow. ठीक है, जो हमें दिया हुआ है, जो हमें cash inflows हमें दिए हुए हैं ठीक है उसको multiply कर देंगे by the respective probabilities. So it will be 40 into 0.20 plus 45 ठीक है into 0.50 plus 50 into 0.30. Okay, so it will be 8 plus 22.5 plus 15. Now we'll sum it up. The answer is rupees 45.5. Okay, so I'll quote it here. It's 45.5 in all the years. Then take this, we've already computed 0.909, 0.826 and 0.751. Then taken we'll multiply it. 41.36, 37 to 0.58, 34.17. Now we'll sum it up. It's coming 113.11. The initial cash outflow in this case is 80 lakhs. Then I have to minus it. So it's 33.11. This is what? This is the NPV. Okay. See, in such cases where the cash inflow in all the years is the same, there is a simpler way to find out the PV of cash inflows. You can compute it like this also. PV of cash inflows. कैसे जो आपका annual cash inflow है उसको multiply कर दो by present value annuity factor R और N. ठीक है, R in the present case is 10% and N is 3 years. So the annual cash inflow is what? 45.5. इसको मल्टीप्लाई कर देंगे बाय प्रेजेंट वैल्यू एनुटी फैक्टर 10% एंड 3, वो हमारा कैसे निकलेगा, विच इज द सम टोटल ऑफ ऑल दीज 3. ठीक है, सो 0.909 प्लस 0.826 प्लस 0.751, इट इज़ 2.486. ठीक है, इसको मल्टीप्लाई कर दो, इट्स कमिंग ₹113.113. clear, which is equivalent to this. Okay, so this is a simple way to find out the PV of cash inflows, where the annual cash inflow is same in all the years. ठीक है, there is no need for you to make the table. ठीक है, फिर इसमें से आप माइनस कर देना आपका initial cash outflow, that will give you the NPV. Okay, so this is the way we have computed the NPV for both the projects, in project X as well as for project Y. Now we'll compare it. In case of project X, the NPV was 37.28. However, in case of project Y, the NPV is 33.11. So based on the NPV criterion, the first part of the question has been asking us that which project is better based on NPV criterion. So based on NPV, project X is better because it has higher NPV in comparison to project Y. Okay, so we'll just write it down here. Based on NPV criteria, project X is better as it has higher NPV in comparison to project Y. Clear? So this is the way the first part will be done. It's very simple. Then let's move on to the second part of the question. Where we need to compute the standard deviation of the PV distribution and analyze the inherent risk of the projects. Okay, so in this way, so here we have to compute the standard deviation for both the projects, project X as well as for project Y. Computation of standard deviation. Okay, so first I'm computing for project X. See, in case of project X, first you will be computing the standard deviation for year 1, year 2 and year 3 separately, and then we are going to compute it consolidated. Now, so let's do it. So the cash flows for year 1 I'm denoting by X. So I'm writing here X. So the figures are, it is 30, then we have 50, and then we have 65. Just write down to the rupees in lakhs. Then probability, it is 0.30, 0.40 and 0.30. Then Px. We'll multiply these X figures by their respective probabilities. So it will be 30 into 0.30, it's 9, 50 into 0.4, it's 2, 65 into 0.3, it is 19.5. Now we'll sum it up. Okay, so here it will be 50 into 0.40, it is 20. Okay, instead of 2 it is 20. Now we will sum it up, so it's coming 48.5. This is X bar. Then we have next column is X minus X bar. So 30 minus 48.5. So it's coming minus 18.5. Then 50 minus 48.5, it's 1.5. And 65 minus 48.5, it is 16.5. Then X minus X bar ka whole square. So 18.5 into 18.5. So it will be positive 342.25. Then 1.5 into 1.5, it is 2.25. And 16.5 into 16.5, it is 272 to get 0.25. Now P into X minus X bar ka whole square. So these figures is multiplied by their probabilities. 342.25 into 0.30. So it's coming 102.675. 2.25 into 0.40, it is 0.90. Then 272 to get 0.25 into 0.30, it is 81.675. Okay, now we'll sum it up. So it's coming 185 to get 0.25. Okay, so for year 1 the SD will be under root 185 to get 0.25. Okay, which is 13.61. Okay, so this is for year 1. Just write it here, year 1. Okay.